Welcome to our deep dive into Reimagining Transportation, Electric versus Public Transit Solutions. In this video, we'll explore the critical facets of both transportation options, from their environmental impacts and energy efficiencies to cost considerations and infrastructure needs. Join us as we examine how these solutions can shape our urban landscapes, address accessibility, and adapt to emerging technologies. We'll also discuss the role of government policies in fostering this evolution and consider what the future holds for integrative transportation systems. 1. Environmental impact. Electric vehicles, EVs, are often celebrated for their ability to produce zero tailpipe emissions, a feature that dramatically reduces air pollution, especially in congested urban areas. However, the environmental benefits of EVs largely hinge on the energy sources used for electricity generation. If the grid is powered by renewable energy, the impact is significantly positive. On the other hand, if electricity is derived from fossil fuels, the net benefit might be less impressive. Public transit, including buses, trains, and subways, offers a different solution by decreasing the number of individual vehicles on the road. This reduction leads to lower overall emissions per passenger, presenting a collective approach to tackling pollution. Public transit's impact is particularly noticeable in densely populated cities where it can replace countless car journeys with just a few train or bus trips. 2. Energy efficiency. Electric vehicles boast a superior energy efficiency compared to traditional internal combustion engine vehicles. EVs convert approximately 60–70% of the energy from the grid into motion, making them a more efficient choice. This efficiency is a significant selling point for EVs, as it means less energy waste and more mileage per charge. Meanwhile, public transit systems, particularly trains, can transport hundreds of passengers at once, using less energy per capita than private cars. Trains, especially, are renowned for their energy efficiency, often running on electricity and capable of moving large groups of people with minimal energy expenditure. This makes public transit an attractive option for energy-conscious urban planners and commuters alike. 3. Cost considerations. When considering cost, electric vehicles come with high upfront prices, which can be a barrier for many potential buyers. However, the long-term benefits include lower operating and maintenance expenses compared to gasoline-powered cars. This is primarily due to the fewer moving parts and less frequent need for servicing. On the flip side, public transit is generally more affordable for passengers. The costs are often kept low thanks to government subsidies, which cover a portion of operational expenses. For many people, especially in urban areas, public transit provides a cost-effective alternative to owning a vehicle, eliminating the need for parking fees, insurance, and fuel costs. 4. Infrastructure requirements. To support the widespread adoption of electric vehicles, extensive infrastructure is necessary, including a network of charging stations, upgrades to the electric grid, and facilities for battery manufacturing. The development of these facilities requires significant investment and planning. In contrast, public transit demands investment in railways, dedicated bus lanes, and station infrastructure. Although these are capital-intensive projects, they serve large populations and can significantly enhance mobility in densely populated areas. The long-term benefits of such infrastructure investments can be seen in improved transit times and reduced urban congestion. 5. Urban space utilization. Electric vehicles, similar to traditional cars, require parking spaces and contribute to traffic congestion in urban settings. Despite their environmental advantages, EVs still occupy valuable city space. Public transit, on the other hand, is inherently more space efficient. Trains and buses can move large numbers of people simultaneously, alleviating road congestion and freeing up space for other uses. In cities where space is at a premium, public transit provides a practical solution to the challenges of urban planning and development. 6. Adoption rates. The market for electric vehicles is experiencing rapid growth, with countries like Norway leading the charge thanks to favorable incentives and policies. These policies include tax breaks, subsidies, and support for charging infrastructure, encouraging more consumers to make the switch. Public transit usage, however, varies widely across the globe. Major cities like Tokyo and New York boast high ridership numbers, driven by dense populations and efficient systems. Public transit in these cities is not only a necessity but a part of everyday life, providing reliable and accessible transport for millions. 7. Accessibility. Electric vehicles offer the convenience of door-to-door travel but remain out of reach for those without the financial means to purchase them. The high initial cost is a significant barrier for many individuals. Public transit systems, conversely, are generally more inclusive. They provide mobility options for a diverse range of individuals, including low-income individuals, seniors, and those without driver's licenses. Public transit is a critical component of urban life, ensuring that everyone has access to essential services and opportunities. 8. Battery technology. Electric vehicles are heavily reliant on lithium-ion batteries, which necessitate the mining of rare earth materials like lithium and cobalt. This raises environmental and ethical concerns, as mining practices can be detrimental to the environment. Public transit systems such as electric trains and trolleys often rely on overhead wires or third rail systems, reducing dependency on onboard batteries. This approach minimizes the environmental impact associated with battery production and disposal. 9. Government policies. Governments around the world are actively incentivizing the adoption of electric vehicles through various measures, including subsidies, tax breaks, and funding for infrastructure. These incentives aim to make EVs more accessible and attractive to consumers. On the other hand, public transit systems receive significant public funding to maintain operations and expand services. This funding is essential for developing and sustaining efficient and reliable transit networks, which are crucial for reducing urban congestion and pollution. 10. Future integration. The future of transportation is likely to see exciting developments in both electric vehicles and public transit systems. Autonomous EV technology is advancing rapidly, with the potential to enable shared and automated transport fleets. This could revolutionize personal mobility, making it more efficient and accessible. Meanwhile, public transit systems are incorporating electric buses and light rail options to modernize fleets and reduce their carbon footprint. These innovations promise to enhance the sustainability and efficiency of urban transportation, offering a glimpse into a cleaner and more connected future.